audible.
Am I audible now?
Yeah.
Okay, yeah, sure. So yeah, like Abhishek was mentioning on the topic, so we will be, talking about application security tools. It'll be an overview of, application security, where, how different tools can be used to basically, look for vulnerabilities, find and fix them, which basically helps, in overall securing the applications. So let's have like a quick look at, the agenda that we have. So we will, talk about a few things on application security testing, basically on what and how, and we'll talk about, vulnerability scanning, and about tools that, that can help us in performing these vulnerability scannings and, application security testing, and and some demos as part of it, which will help us understand maybe these concepts are little better. And yeah, we'll be mainly talking about these concepts on SaaS, DAST, SE, and a couple of things on pen testing. So yeah, I think the overall this should take around 40 to 45 minutes, is something that, I think they should go for. And I think in the end we can have like Q&A, and if there is anything in between, I think you can still, put your questions in the chat. I think we can still discuss on that. Abhishek, I still see like, a couple of comments saying voice is low. Is it still low, or is there should I connect like your phone or something?
Yeah, I think it would be preferable if you can connect your phone. I think the audio quality improves then.
Just a second, folks. Sorry about that. Let me do that. Is this better?
Yeah, I think you can just adjust your volume and the WebEx so that.
Yeah. Is this better
Your
now?
audio is still a little low. Uh, if you're closer to your mic, then.
Is this better now?
Oh yeah, this is much better. Yeah.
Okay. I think I'll just use this. Sharing my screen back. Oh yeah. We will again, just a quick thing about the agenda again. So we will again be talking about SaaS, DAST, SE, and Pentest. Yeah, moving on. A quick overview of few things, on application security testing, like what exactly is it, right? So it's basically making sure the applications are more resistant to security threats by identifying issues before a bad actor does it, right? So application security testing, it basically started as a manual process, but due to fast growing companies, developments, and even the vulnerabilities that that are discovered, and the fast growing open source community, so this has to be automated to keep up with all these things, right? So currently a combination of this is used, where there is a part of it where automated testing is also used, and there's a part where a manual process still happens. So basically it's a combination of both the things that will be used. So we'll touch upon both automated and manual methodologies and process, and see a few tools that can be used on the discussed topics. Yeah, so there are like different types of testing, when we talk about application security testing. So and it and talking about specifically on automated testing, like SaaS, DAST, SEA, are few things that can be seen that through the SDLC cycle, right? And pen testing is something that comes under the manual part. And yeah, so these there are like different approaches that can be taken when we talk about application security testing. Like basically they're categorized into three different categories. So one is called black box, gray box, and white box. So black box testing is a type of testing where where the assessor basically has no knowledge on what the target is about. So it'll be a blind assessment where they try to figure things by themselves by looking at the target and stuff. And gray box is something where before I talk about gray box, maybe I'll explain what white box is. So white box is something where where all possible details are available for the assessor, where he can have all the information that is out there. And talking about gray box, it is somewhere in between black box and white box, where there are like some information that is given out, which is not like just to give some example, right? So we talk about testing a application. Black box can be something where where the tester has just the URL of the application and nothing much. Everything else is figured out in the process of the assessment. So white box is where they will also have access to the source code. Basically, source code, if they have access to the source code, basically they have the whole code in front of them. They can understand and also know what exactly is happening. So gray box is something where let's say they have an application and they have application and basically they have like some credentials for that application and not like a whole source code or anything else, right? Not much information. It's like a restricted information. So this is how these three things can be considered. Yeah, moving on, we'll talk about a little more on application security testing, right? So so we'll take a different approach to to understand what this is about and how and what exactly happens by taking an example of a very simple version of SDLC, where we categorize these things into four different phases, right? So that is like development, commit, build, and deploy. So let me tell what exactly these things are. So considering application development, so let's say to start with, developers write code, right? That is how the development begins. And once they write the code, they push it to a centralized repository, like code repository. So let's say just to take an example, these things can be like GitHub, GitLab, Bitbucket. These are like some examples, Git-based version controlling systems where you can put your code, which will be stored centrally. And once you push the code, basically what happens is this is when it is built. So build is, I mean, this is the place where the application is integrated, where just to put it in simple terms, like the source code is compiled. And then once everything is ready, it is deployed. This is where you can get the final product, where people can start using the application by going to a website and accessing a URL. So we understand like all these things, but talking about application security, what is that we'll have to look at here? Like, what do we test and where do we test? To understand this, like, let's go further. I'll break this down into these different phases. So let's go through each of these phases and see like what can go wrong and what can we look at and what happens here, right? So in this particular specific phase, in the development phase, right? The code is written. So let's say the developers, they write their code, and this is where vulnerabilities like vulnerabilities that are related to code can be found. So something like SQL injections. I mean, we will talk about what SQL injections are, but application related vulnerabilities like SQL injection, cross-site scripting. These are like few vulnerabilities that we can look at, which will be introduced in this particular phase, because this is where the code is written. And one other thing to talk about is whenever application is developed, there'll be cases where a lot of third party or a lot of other integrations that happens with some other tools. So when this happens, like usually they'll be authenticated, which requires a password or a secret to connect to that. So let's say, for example, we have an application and we need to connect to a database. So if we want to connect to a database, the database will also have like a login, right? Like it'll have a username and a password that should be used to connect. And these credentials sometimes will be, hard coded. I mean, that'll be hard coded in the sense that'll be present in the code where, it can be, I'll just move to the next slide. I think this will be a little easier to understand. So if you can look at this, like, the database name and the secret key is something that is passed as a variable, right? So this is basically hard coding, and when it is being developed, I mean, it is still bad. The credential should not be hard coded. It should be always stored in a secure place, like a vulnerability or secret management, uh, tool. So, I mean, when it is in the development phase, basically the previous phase, yeah, this phase that we were talking about, it'll be in the developer's local machine. It is bad, but still it'll be contained in that specific machine. But when we talk about the commit phase, right? Here, this is where the code is pushed to a centralized repository. So let's say something like a GitHub or GitLab, where the visibility is visibility is more because a lot of other people will have access to this code, and having secrets there is very bad idea, right? So this is like the other problem that we can see in the commit phase. um, Moving on, I think we have like some interesting cases here in build phase. So let's take a step back and understand what this is about, right? So while developing application, usually what happens is people tend to reuse code. I mean, not everything is written from scratch because there are libraries out there which can be used to perform these things. So reusage is like one of the things that is done a lot. There are places where copy paste is done, right? And and reuse in the sense there are like external third party libraries which can be used to perform like a lot of activities. Like let's say we need to connect to a database. The connection is not like written from scratch. There'll be a library that will be used where that can be imported and basically used to connect to the database. So similarly, like there are a lot of other libraries that can be used, and this is like this is also called as dependencies. So, code behind this will not be in developers' control because they would have not developed it. So they would have used it from some other place. And usually there'll be a lot of third-party libraries that'll be involved whenever there is a development. And a small vulnerability that is present in a third-party library can affect the application that they are developing or the code that they have written. So just to have a understanding of how or what can go wrong, or how bad it might look like. There's a case study. This happened some time back. Basically this is an example from British Airways. So what happened was their application, they were using a third-party JavaScript library, which was vulnerable to a vulnerability called XSS, that is cross-site scripting. So this is a place where users can make their transactions. Like let's say uh, users can make transactions and where they make payment. So they can make payment. So this is where the vulnerability was, where these attackers, which I mean the third-party library that was vulnerable, they use this to skim the card information and stuff, which normal users use to make transactions. And because of this, I think like you can see that like, there were like 400,000 plus transactions that was skimmed in 14 days, and British it was fined for over 20 million dollars for the GDPR violations because this was not supposed to happen, right? And all this happened just because they were using a third-party library which was vulnerable to a specific vulnerability. And this is not even written by the developers developing the British Airway application. This was a library that was just imported. This is something that we can see in the build phase. Moving on the deployment phase, right? Uh, so what happens here is, the whole application is packed and it will be ready to use. So till now we were looking at the code. This will contain other components too, like, for running a application. So like a server, a database, web application firewall. This is something we can say, like, a layer which we can, or people try to put so that, a lot of attacks can be blocked. So there's another example based on this, that happened, where, Capital One is one other example that we can look at. So here, what happened was they were using a WAF, basically a web application firewall for their server or their application, and this web application firewall was misconfigured, and which was vulnerable to another attack called server-side request forgery. And we will talk about what the issue is about, but just to understand, this is like a infrastructure level issue or a misconfiguration that happened on web application firewall, and basically the attackers were able to get a lot of information out from their servers because of this small misconfiguration. And again, like 1 or 2 million people were affected and $80 million was fined. So these are like some kind of vulnerabilities or something that can go wrong in each of these phases, right? So moving on, right? So now that we know like what can go wrong and where we can look at, let's talk about SAST. SAST is basically static application security testing. And this is basically analyzing code to find security flaws, and this helps find security flaws very early in the life cycle, because this can be started from when the code is being written or it is pushed to a central repository, right? So this is way before the application is built or deployed. So this helps in finding defects or flaws very early in the development life cycle. So this can again be done in two places. So let's say, like, whenever a application or a code is written, how it happens is, like, usually developers will have a IDE or a place where they write their code, right? And and the other part is where they commit. So what can happen is there are few plugins which will help plugins that can be installed in the developers IDE, which will help detect vulnerabilities as and when they write the code, as soon as they save the file, right? So that is something that is very early in the life cycle, before even they push the code to a central repository. Or what can happen is the other way is where once they push the code to a central repository, SAST is again analyzing or scanning of the source code can again happen there. Like this is like the other place that can happen. But we'll still deep dive and understand like what this is and how can this help us, and basically see like what kind of results that we can get from this. So so okay, I mean SAST is again, like we were talking earlier about white box, black box, and gray box. SAST is a white box approach because we have access to the source code of the application, and it looks for code patterns which might have vulnerabilities, and this is how the workflow looks like of a SAST tool. So on towards the right, so basically the code that is written by the developers, like it can be in any language like PHP, Golang, Java. So that is pushed to a central repository like GitHub, where where a scanner will pick this particular thing up as soon as the code is pushed to a repository. And usually this will be configured in different ways on how to run the scans. So it can like we were talking about earlier, like this can be scanned as soon as there is a new code that is pushed to the repository, or there can be a frequent scans that can be done. Like basically the frequency can be defined saying that on a specific repository that is present, once a day there can be a SAST scan that can that can be run and basically see the output. So okay, so this is what this rule engine does, or the scanner. So the scanner picks up this particular code and it analyzes the code. With a set of rules. Rules are the patterns which are used to detect a vulnerability. We will see what rules are, like how a rule might look like and stuff like that, right? So whenever there is a scanner that is being used, there'll be few language specific rules that can be used. That'll be there by default, and there will be option where users can write their own custom rules, which on their own experience or anything that they want to be done customly, like they can use that. So once this is done, the scanner picks up these rules. It'll analyze the code that is pushed and basically look for defects and see if there is anything wrong. And basically, it'll give a list of defects in the end, saying that these are the issues that it can see in the code that was pushed. So yeah. So this is how the whole process of SAST looks like, right? So and one thing about SAST is it's language specific. So a rule written for PHP may not be applicable to Golang or Java, right? So this is like one of the things that that has to be kept in mind when using a SAST tool, because not few rules are not universal, like they can't be used for any language. And talking about few tools, there are like few very good tools which helps in which helps in SAST. So one major thing that we will also see, like how this works in a quick demo. So it's called Semgrep. There is another thing called Code Sweep. This is also something that we'll look at in the coming slides. There are other tools like SonarQube, Veracode, AppScan. These are like few tools that can be used for performing SAST. Okay, so before, we do have a quick demo of SAST on how SAST looks like. So before we do that, let's talk about a quick we are just going to pick up a example of SQL injection. This is a vulnerability. Basically, I'll give a gist of what this vulnerability is about, so that we can use this vulnerability and see how tools can find this particular vulnerability. So I'll just give a brief of what SQL injection is. So right. So basically, let's say this is again which revolves around database and querying database and stuff. So let's take a simple example. So let's say we have just to pick up anything that we use every day. So let's say we order food and stuff, right? So basically, when we like let's pick up a very simple, let's say authentication form, or where a place where you log in. So what happens is when we log in, we have to use our username and password. And for this, when we enter username and password, there will be a mechanism which checks whether what you have entered is correct or not. And for the application to verify this should be stored somewhere in the database, right? Like the username and password should be stored somewhere in the database, so that it knows what you are entering is correct or not. So what happens here in the background is let's assume this is like some application that is written in PHP, and we have a MySQL database or something that is running in the background. So what it does is when you enter your username and password, it queries the database saying this is the username, is the password correct or not. If it is correct, it'll get something back saying okay, this is correct. So what happens is the query might look something very similar to what we are seeing here in the backend. Something like select, here I have a small different example where getting ID and from getting ID of where we are passing of a basket, from where we are passing ID of that particular basket. So like we are talking about this example on username and password. So it looks something like this. It might look something like select user from users, where user ID is equal to, or username is equal to, that'll be the user input what the user will be passing. So what happens is when we give that, it gives out a valid ID, and basically you'll be authenticated and you can proceed. But talking about SQL injection, it's basically a vulnerability. It's a flaw. So where what happens is a database cannot differentiate between a query and a user input. I mean, instead of picking username, let's say, it's a username, let's say it is Suchit. Instead of picking Suchit, if a user enters Suchit a single quote, what happens is it'll not know Suchit single quote is a user input, and it'll assume or consider that as a query. So basically, anything that is passed, the database will not be able to differentiate if it is a query or a user input. So this is what basically goes wrong when we talk about SQL injection. So where these where the attackers can pass malicious input and try to extract something out from the database which is not intended to be sent out, which will again see like how this can go wrong. But considering this is one of the examples, we will be trying to look at SQL injection and see how our attack or sorry how our vulnerability scanning can help us in finding this particular specific vulnerability, like SAST for this case. Okay, just to have a look at the demo, like we were talking about one thing earlier on, finding vulnerabilities while the user develops or writes their code in their IDs, right? So this is one thing that we can look at. Basically, this is a Visual Studio Code, and there is this particular extension called Code Sweep from AppScan. So what it does is, if you can observe this, the user is typing their code and they save it. Once it is saved, it gives out a pop-up saying there are 3 issues that it found. So and it basically gives out a vulnerability is right there whenever they as soon as they type their code. And this is like one of the things which is used way early in the development cycle, where they can easily find and avoid security vulnerabilities. And we'll have a quick demo. Basically, we'll see how we spoke about this tool called Semgrep. So we'll see like how Semgrep works. Yeah, we'll quickly have a look at this. So here, I do have a code of which is basically written in PHP. It is vulnerable. It's a vulnerable application. I'll share some references for this application or this repository, in the end, where you can look at what this is about and stuff. And here, there are a bunch of PHP code, and there are like few places which is vulnerable to SQL injection. And here we'll see how the SaaS tool Semgrep in this case here can help us find this particular vulnerability. So here, like what I'm trying to do is basically run this tool Semgrep, and this is called where we were talking about rules, where there'll be a custom or a generic rule that'll be written, language specific rule. Here it's a specific rule to find SQL injection that we'll be using with the tool Semgrep. And we can find these rules from the Semgrep's rule registry that I'll paste the link that you can take a look at. So what it does is it basically scans. Here, if we can see this, it ran 47 rules on 8 files, and it found 2 findings. Basically, there were 2 instances of SQL injections that was vulnerable, and it was run on this whole folder, right? So it scanned 8 files. So here we can look at this, where this tool actually found SQL injection, just by running it on the source code that we have here. And just to have a look at how the source code look like, this is the place, or this is the file which is vulnerable for vulnerable to SQL injection. And here, if you look at the result, it says line number 10 right here. It says line number 10 and line number 31, which is vulnerable to SQL injection. So here, if we see line 10 is a SQL query, which says select first name, last name from users, where user ID equals, this is a $ID, right? This $ID is a user input that is coming from the web application. So it is a request has a parameter called ID that is directly passed to SQL query. And whenever user input is directly passed without any validation, sanitization to SQL query, this causes SQL injection, because anyone can pass anything as part of their input. Instead of passing ID 1, if I put IDs 1 single quote or 1 = 1. Basically, it will take that whole thing as a SQL query instead of a user input, and it executes the query. So yeah, this is how the vulnerability looks like, and this is how the tool works, right? And just looking at the other result that we found on line 31, it's very similar to the earlier one. So yeah, this is how a SaaS tool can help us detect a vulnerability. And talking about the rules here, in this case, the rule that we used for SQL injection, this is how it looks like. So basically, there will be a bunch of patterns that will be written, which will be able to detect the vulnerable sequence or vulnerable SQL query that is written. If you, I mean, it looks up a little complicated, but basically it is looking for things like keywords such as select, delete, insert. Basically, it's just doing that, and it sees if whether it is coming from a request or not, and it'll look if there is a variable that is present, and with all these patterns, it'll say if it is a vulnerability or not. I mean, these are like a little complex just to understand directly. So what I'll do is I'll paste some references where you can still go ahead and spend some more time and try to understand how these things look like, and also like put your hands on and try to run some rules on uh, some of the code that you own. So yeah, you can still use some vulnerable code that I'll be sharing by the end. Moving on. So the other part that we have as part of application security testing is that we can look at is software composition analysis. So before we talk about what exactly this is, let me start it with a different way. Let's say, like let's talk about application, and let's say so let's say it uses. So what we are seeing here is a Python application that we can see. There is a run.py and requirement.txt and stuff. So whenever a Python application is written, what happens is usually there are chances where people will be using third-party libraries. So here, these what we are looking at here in the red box are the libraries that are externally a third-party libraries that are out there. People can reuse this and make use of the code, and it helps or makes their life easy. And usually when a Python application is done, there'll be a file called requirement.txt, which contains all the dependencies or the libraries that is used. That is exactly what we are seeing here. So if you look at this, there are 18 external libraries that are being used. So here, right, like we are using 18 libraries, but we don't have the code of these 18 libraries, right? We have not written it. I mean, we can still get it, but we have not written the code. So this is written by someone else, and we are just using it. How do we know when and if there is a vulnerability present in this particular library, right? So because if there is one single vulnerability that is present, like how we saw earlier in the example of British Airways, right? They were exactly doing the same, where they were using a third party library, something like this, and there was a vulnerability that was not known. So exactly in this case, like how will we know if there is a vulnerability in any of these 18 libraries that we are using? And if there is a way where we can see if there are any existing vulnerabilities that we can look at, right? So this is exactly where SCA comes into the picture, where it's basically SCA is software composition analysis, right? So basically what it does is it is used for getting or looking for vulnerabilities that are present in third party or open source components. So there will be a database which contains like a mapping of vulnerability and the library. So basically this is what it does. It looks for use third party components and see if there are any known vulnerabilities that are present. Yeah. So I just have like a quick thing. This is how it looks like. There's code. There'll be like multiple libraries that are used, and there might be known vulnerabilities, right? So SCA, what it does is it scans for libraries, detects known vulnerabilities, and it also monitors for new vulnerabilities whenever it is it is run in a sequence, or when it is run in repeated frequency. There are like bunch of tools that that can be used for SCA. Dependabot is one of the tools that we can look at. Dependency check is one tool that is very specific to Java, and safety is one other tool that is, again, specific to Python, which looks for Python dependencies and libraries. We have like a very quick demo on SEA2. Let me quickly switch over to that. So again, this is another vulnerable application that we are looking at here. And this is exactly the application that we saw in the first slide, like a couple of slides back, where we were looking at the dependencies. So this application has like around 18 dependencies and a couple of Python files. So what we do is we basically oh, and one other thing is, if you can observe, like a library has a version, like a version associated with this, saying that this particular or specific version of this particular library that we are using. And yeah, so in this case we are using this tool called safety, and this safety, what it does is it basically looks for all these vulnerabilities, sorry, all these libraries, and looks if there and checks if there are any vulnerabilities that are present in the library. So here, if we look at the results that it got around 9 vulnerabilities from scanning that particular file where the dependencies were mentioned. So it says, this is the library and this is the version that it is looking at. And it says there is a vulnerability that is present here, and it gives an ID for that. And it also says, this vulnerability is affected by this and can be updated to a available existing or updated version, which has a fix for that particular vulnerability. So this is the data that we can get by running SEA tools, where we get like information on existing vulnerabilities that are present in third-party libraries. Moving back. So yeah, so again, when we were talking about the tools once more, Dependabot is one of the tools that can be used. It supports a bunch of languages, which I'll again be sharing, because and I think there are a lot of things that we have which we can look at, but we don't have like much time to go in depth of everything, so that so I'll be sharing a bunch of references. I think that should help understanding each of these tools and topics. So dependency check is one of the tool that is from Project Wasp. It's more specific to Java, and I'll again be sharing that. And safety is the one that we just looked at. So moving on to the next phase, this is where we talk about DAST. DAST is dynamic application security testing. So so far what we looked at is either while developing a code or developing an application, that is while writing a code, or once the code is pushed to a repository, or I think the other case was where the application or the code was built. And Dash comes in a picture when the the application is deployed. I mean, towards the end of the cycle, right? So once the application is available for users to use, let's say you have a URL associated to that, and you can basically use it from a browser. This is where this comes into the picture. And again, categorizing this to one of the areas that we discussed on white box, gray box, and black box. Dast comes under black box because I mean it comes under two different categories, and sometimes it comes under black box, and sometimes it can also come under a gray box, because there are cases where you can still get like some credentials or some information regarding the application. Yeah. So yeah, again, this also helps detecting vulnerabilities, and basically this also helps detecting the same vulnerabilities that the other tools or other types of testing helps. But DAST helps in a couple of different areas which the other tools can't. So one of these is the infrastructure related issues, because code will not have the context of infrastructure, and runtime and environment related issues is again like something that code might not have access to, right? So this is where DAS comes into the picture. It works a little differently than how the other things that we saw. So what DAS does is, like we can see in this particular, the small diagram that we have. So, our live request is made to the target application. So let's say we have a application running. Here what happens is this particular tool will make a call to that particular application. Like it sends whatever the protocol, like, HTTP or HTTPS it is using. It'll make a call using this protocol, but it not just send normal requests, right? Here what it does is it'll try to send some malicious payloads or requests. And it works a little similar to the previous cases, where this will have a set of rules. Basically, it says it'll have a pattern saying that this pattern might get this response. If it gets this kind of response, then it is vulnerable. If not, it is not vulnerable. So this is what it looks for. And this is like, how DAST works. And again, there are like bunch of tools that are again available for DAST. Bob is like one of the tool that is majorly used for DAST and also for pen testing. Nuclei is one of the tools, and Zap. So we will be looking at a quick demo on Nuclei, on how Nuclei can be used for DAST. So let me quickly switch over. So here we are looking at, this is a vulnerable application that I've locally hosted. I mean, this is in my own environment. We should not be running this particular task tools anywhere on any public applications that we find. I mean, that should not be done without permission. And we should be responsible and make sure that we don't run these kind of tools on any production system without having a prior permission. If you want to try this out, please do host your own environments, which I'll be sharing the reference for. And you can run these tools in your local environment so that nothing is affected. So just to take a quick look at this, the DAST. So here, this is the application that we have, and this request that, how it looks like. So basically, if I enter a number, it gives me the first name and, a surname. So again, this is vulnerable to SQL injection. I mean, it's a vulnerable application, but we will try to detect this using DAST. I mean, using this tool called Nuclei. This is how it looks like. Nuclei is the command and the tool. And there are a couple of options that we pass. One is the URL of the application. Two is the template. Template is basically the rule that, which is used to match the pattern and see if it is vulnerable or not. So once this is done, what it does is it basically sends a request to this particular application that we are seeing, and it waits for the response. I mean, it waits to get the response back. Once it has the response, it basically checks whether the response matches to a vulnerable condition. If it is yes, it'll tell this is a vulnerability and it is detected. It has detected this. If not, it says nothing found. So in this case, it says this vulnerability is found. So we'll quickly look at a couple of more things and just show like how the rule looks like, right? This is how the Nuclei rule looks like. Here, what we are doing is we are passing a single quote in the parameter called ID, and this is the request that the tool sends to the application. And looking at the response, what it does is here we have a couple of conditions that we are seeing, where it looks for this specific keyword, you have an error in your SQL syntax. And it checks for the response status is 200. If it matches both the conditions, it says, this is vulnerable. So this is exactly what happening, in this case. And yeah, so just to look at, how it looks from a browser, we have, we have a single quote entered here. This is what the rule is also doing, the Nuclei tool. And this is the response that it gives. And this is what it is exactly checking. If this is present, it says it is vulnerable. So this process is automated by, using the tool. Yeah, moving back to the slide. And yeah, exactly. This is a rule that we just saw, the Nuclei rule for finding SQL injection. And this specific rule is specifically for this application, that there's a custom rule that was written, right? This may not directly work for some other application. This might not match the pattern. So the concept of custom templates and generic ones is where that it comes into the picture, where if there is a custom requirement that we need, we can write a template like this. And let's say, just to give an example, so let's say we have 100 applications that we are running, and everything is very similar to how what we just saw. This case, if we want to make sure or check if this particular vulnerability is present, and if we want to do that manually, we have to look at 100 different applications and basically send a single quote and see what is the response that we get back. And by looking at that, we'll know if it is vulnerable or not. And this has to be done 100 times to check all the 100 applications, right? So this is where DAST helps. Where, let's say, this is one of the one of the things that we can make use of, where a generic rule can be written, and just the URL can be different. So that we can pass the URL to the application, and this particular tool will basically do the whole process and give the results within minutes. uh, it's faster and it is automated, because it does not require a human interaction for every single thing, right? So this is how the automation part of this works like. And just an overview, like we have looked at SAST on two different phases, that is development phase and commit phase, where we have talked about how it can be used in a plugin and how it can be run on the code. And we spoke about build phase, where SCA can come into picture, where we can look at vulnerabilities that are present in third parties or dependencies, libraries or dependencies. And in the deployment phase is where we saw DAST. That is where we interact with the application and try to get the basically see if it is vulnerable or not. So far that we saw, it was all the automated tools and approaches. We'll quickly take a look at couple of manual approaches. I think we are also short on time, so we'll take a look at a couple of manual approach which can help us identify few issues. So this specific thing, usually I personally use, where when I want to try, or when I want to look at a specific thing, or when I'm not sure what I'm looking at, and basically pass patterns, regular expressions and stuff, and try to identify it, right? So this is one of the tools that that is very helpful. It's called GitHub code search. This is from GitHub, and this only works if you are looking at specifically at GitHub, and if your code is on GitHub, right? So we'll just quickly take a look at what can be done using this. So what GitHub code search is basically, it is a way to search your code by giving certain patterns, regular expressions. So based on that, it matches the whole code base, and it'll give out the result which matches whatever your search query is. So just as an example, like we were looking at previously on SQL injection, this is exactly the repo that that I was using to demo and stuff. And so I'll just quickly explain what is that, what is it that is going on here. So to search, my end goal here is to find SQL injection, but this is a manual approach, right? So I want to look at a pattern where let's say I'm this is very I've simplified just to showcase how this can be used, this tool can be used. So here what I'm trying to do is I'm trying to look for a pattern which basically starts from select and has some data in between, and has a dollar in the end. So basically, if you can look at this, what I do is we can make use of certain filters, like repo is one of the filters which has the repo name from GitHub. Path is something that we can use, where we can give regular expressions like star. Star means anything, and that ends with .php. And the third section is the regular expressions. Basically, this is something that I use to match a specific pattern. So here what is happening when I use this particular thing, select and these regular expressions, it'll give me like a lot of results which will match this particular pattern. And here if we see, it gives me a result from this specific PHP file. And if you observe this, right, this line number is 10 here, and it says this is the line, and line number 31, and this is the line. And this is exactly what SEMGRUB gave us when we run, when we ran the SAS part. So this is just a manual approach, which can be used for a lot of different things. But the idea here is to understand what is that we can do, and what is the tool that we can use to perform a scan. Moving on, we have a small topic. I mean, again, this is talking about pen testing. We'll quickly talk about a couple of things on pen testing, like what are the phases and how a pen testing looks like. Uh, so pen testing is again something where like how we saw about these other approaches on SAS, DAST, SCA and stuff, basically to identify vulnerabilities, right? Pen testing is also very similar, where our end goal is to identify a vulnerability and make sure that it's fixed. So for that, this is a manual approach where we try to do a bunch of steps that we take, and bunch of tests that we perform to basically find some vulnerabilities. So let's quickly go over the phases that we have in as part of pen testing. So usually a pen test is it starts with a phase which is called planning, where basically you plan what is your assessment, and what is that you're trying to scan. So basically, defining scope, saying that, okay, this application is something that I'm looking at. This is what I want to, get from this application. Once we have that, what happens is we move to the next phase called reconnaissance, which is basically gathering information. So once we know, okay, this is the application that we want to look at, we try to gather information about that particular application, on what is it running, what kind of application is it, what language is it using, what kind of database is it using, what is the infrastructure, what frameworks are being used, things like this. So once we have the required information, we move to phase 3, where a bunch of manual and automated tests goes out there, where we look for the application, how the application behaves for the inputs that is passed by the user and stuff, right? So this is where a lot of work goes into, where where the people who are trying to work on a pen test try to find vulnerabilities, like how we saw the tool find vulnerabilities like SQL injection using SAS, DAST, right? So the same things. So what these tools they do is they try to identify a vulnerability is present or not. But what a pen test gives is what else can be done. Like basically, we know a vulnerability is there, but what is the impact? What can this particular vulnerability can cause is something pen test gives us, saying, okay, getting a SQL injection, getting an error from SQL injection does not have an impact, right? Because it gives an error. I mean, there is nothing that we're getting from the error. But what can be done with that vulnerability is something that we can look here. Like, let's say we can dump the whole database, or we can get a shell, or we can shut down a database. These are the things that we can look at from a pen test perspective. So once we gather vulnerabilities like SQL injection, cross-site scripting, the next phase is reporting. So what happens is the reporting phase will contain details of the tests that were performed, the vulnerabilities that were found, how to fix it and stuff. Uh, and the required details that are required are to reproduce the steps that was taken to find the vulnerability and exploit it. Once this is done, is the next phase where we look at patching these vulnerabilities. So this is the whole cycle where it starts from planning and ends at patching. And basically a lot of tests that is that will be performed during the phase 3, that is manual and automated tests. So these test cases is what it is called. I will be sharing a lot of references from OWASP and couple of other couple of other references. So we can take a look at how this is done. We're trying to understand what are the tools and techniques that are present, right? So and I think these references will help understand the process that it takes, or the steps or test cases that it contains. So yeah, one I think this we're almost done. We just have like one section for the tools. That one of the major tools that is used for pen testing, that is called burp. I think this is something that we also saw in DAST, burp and zap. This is also used in pen testing. Burp has this thing called a proxy, where a request that is sent from a browser can be intercepted, and you know can be there can be some modifications that can be made for the request, and it can be sent to the server. And if you can look at the screenshot here that we have, the image, the left section is the request. This is how the request that goes to a server looks like, and this is the response on the right side. This is a response that we get from the server, right? This is how it looks like. And what this tool does is, a request that is going from browser can be intercepted like this, and any of the details that you're looking at here in the screen can be modified, and that can be passed to a server in the end. So this helps a lot in looking for vulnerabilities, performing a lot of test cases during pen test. So this is like one major tool that will be used, and there are like bunch of other tools like GoBuster, FFUF, where I'll be sharing some references that we can look at, which which will give a lot more details on on how the tool works. So the tools are very similar to what we saw, but it will have some tweaks and features, additional features that can help us. But the concept should be something very similar. So I think these are things that we had. I think I'll be ending the slides. I think we can go for the Q&A if we have any questions, folks.
Thank you, Suchit. That was a very nice talk that you have delivered, and I'm sure it has aroused the curiosity of all our participants with regard to the 4 areas that you had spoken about: SAST, DAST, SEA, and pen testing. It was a very good introductory overview, and I'm sure they'll have their own threads, and they'll have their own thought processes going forward from there. Now, I'd like to request the participants to please put their questions in the chat box. So, Suchit, I think we can wait a couple of minutes and
Sure,
check
yeah.
the chat box. Yeah. Participants, please paste your queries in the chat box. Okay, we have a question from Shaheen Banu. She is asking about short video which gives a demo of the nuclei tool.
Sorry, is it required for me to explain the part again?
No, she is asking for a short video. If you have a link to a short video that gives the
Okay, I think I can share the links. I mean, Abhishek, is there a way where I can share some references?
yeah, you can share. If they're all web references, then what we'll do is in your webinar homepage on the SciSec website, we'll include it there under the description box. So
Okay.
anybody who visits the web page will be able to access those references.
Okay.
Yeah. So to the participants, all the references that will be shared by Suchit, we will put those up on the webinar homepage on the SciSec website. So you can, anytime you visit the webinar homepage, you can definitely access those resources. So any other questions? Any other questions regarding the technology, the mode of injection, any other question about detection? Please put it in the chat box.
I do have like some references about what we spoke about today that I can
Yeah, you
I can
can
also
send
share in
those
the chat.
across by mail, and we will, put those on the webinar homepage.
Sure. Yeah. Okay. I think yeah that'll be better. I guess I think the chat has some restriction on the size.
Yeah, correct. The chat will have a restriction, so the chat box is not the right place. Yeah, so we've got one interesting question by Prajwal, who asks that can you give any tips for preparation for the OSCP?
Uh, sure. Yeah. I mean, OCP is it's okay. Just to give some information on that. I mean, it's morely revolves around one of the phases that we spoke about in pen testing is information gathering, right? So OSCP revolves around information gathering. So the tip that I would say is there are a lot of resources that is available online, a lot of sources, things like Hack the Box, OneHub. These are like some free resources that you can make use of to practice your approach, practice your way of information gathering, and basically the techniques that is used. I think these are like few things that that helps a lot. And I think one major thing is again is practicing your techniques. So I think practice is something that should be that is very important for this particular OCP certification. So I think that is what I would suggest.
Yeah, so Prajwal, I hope that answers your question about preparation for the OSCP certification. Okay, then Megha asks a question about do you have a link to a short video on cloud computing tool demo?
um Megha, so cloud computing again, I think that is again a very huge topic. And when you talk about tool, I mean, is that something that you are referring to? Is something like a security tool that we looked at? Is it something related to that? If yes, there are like a couple of things that I can share. Like there are few tools like ScoutSuit that that you can just Google. I think you'll get a lot of references on that. And there are few vulnerable instances that you can still use. Let me see if I can say I can quickly find a reference, and I can meanwhile paste it in the chat. So this is I've pasted one chat, which is called ScoutSuit, which is a bunch of tools that helps you in cloud auditing. um, yeah, I think this is something that you can look at.
Yeah, okay. So Megha, please go through this link and access CloudSuite, and I hope that addresses your question. Then we have Manoj who asks a question: how do we use Nmap?
Okay, so Nmap is again it goes a little towards the network side of it. Again, it's a very huge tool, lot of things that can be done with that, identifying ports and services and stuff. What I would suggest is again I can share some references, because explaining the whole tool is again a separate whole topic. So what I can quickly share some references that can help you to get like more insights on Nmap.
Yeah, Sujit, you can share that with us and we'll host it on the webinar homepage.
Yeah, yeah.
Yeah, now there's a question from Chuda who says, can you give some points on the contrast assess tool?
Um, is that like the is that the tool that you're referring to? I mean, again, it's one of the other tool which is again into to find vulnerabilities. um, I mean, points in the sense, what exactly is that you're looking at? Like, something like how it works, or morely towards, how is it compared to other tools or something like that?
Yeah, so Chuda, if you understood what Suchit said, can you just respond to that on the chat? Which type of tool are you exactly looking for?
So okay, I'll generically answer this. So basically, there are a bunch of tools, right? Like how we were talking about SAS and that's like where there were tools like Burp or Zap, Nuclei. These are like a bunch of tools which are used for the same purpose, but each of these tools have its own pros and cons. Like some tool might be better at let's say Nuclei is very good in adding new custom templates, which is very easier for us. But when it comes to Burp, they do give us certain templates that is predefined, and we don't get a lot to modify in that case, right? So there are like pros and cons, but in the end, all these tools tend to do something very similar. Try to look for vulnerabilities in the application. So we have a lot of tools like this. Like Acuinetics is one of the things. Netpacker is one of the things. Like AppScan is like another tool. Burp itself has a scanner. So this is also very similar to that. Again, there are pros and cons on what other advantages that you might get in this in a specific tool. But otherwise, that basically these kind of tools usually tend to find application vulnerabilities, like what we saw, like SQL injections, right? So this is how basically. This is what the tools do, and again, these tools will have some sort of pros and cons. That I think once if we look at this particular tool, I think we can get like more details on what are the things that we can perform with a given tool. So I would say. So understanding the tools, like it depends again on the requirement. So for me, my requirement can be something where I'm looking at something where Nuclei can be a very good tool for me, and maybe your requirement is something where let's say Zap is something that something that can be very helpful. So all these tools, I mean, not everyone will find a tool very useful because of the scenarios or the the structure of their application that that is present, right? So it very much depends on what kind of what is your tech stack that you're using. Basically depends on that, which will have to be which well doing a trial run on or a demo on a particular tool can help understand this. So just to give a quick understanding, so or example, so like we saw about let me give a okay like SCA, like software composition analysis. So what happened in that case is the demo that we saw, it was on Python. So this specific tool that we use, safety, is specifically written in a way where it detects only Python related vulnerabilities or Python related dependencies. But there are like other tools, like dependency check is one another tool, which is mainly for Java based application, right? So if I have a Python based application, I tend to use safety and not depend on a dependency check, because that doesn't work for me. So it's very similar to this. Depends on the cases and use cases. We can decide or come to a conclusion on a particular tool.
So depending on the type of case and use case and on the type of language or platform used by the application, I think you need to decide on either one tool or a combination of tools to determine the level of security threat to the application. Okay. So we have a question from Jyoti, who asks how to use
I think
NESUES
it's
tool.
Nessus. So again, Nessus is another tool again for network scanning. Again, it's a whole different topic again, where it covers a lot of things. Where just to take an example, how Nmap works. Nmap is something which tries to identify a port based on like bunch of signatures and stuff, and then try to identify the services. So again, on the network part of it, right? So Nessus is also, that is very similar to or also performs some similar actions where you can identify a network or infrastructure or system related vulnerabilities. Again, these are all bunch of tools based on your requirement that can be used. But again, the purpose is that if you are looking at application, there are like a lot of tools that are available for performing security tests on application. Similarly, on network, we have a lot of tools, including Nessus, which can be used for performing network scans and stuff. So yeah, I mean, again, like I was talking about earlier, like it depends on the use cases. But coming to the question on how to use it, again, I would say Nessus docs should be the first place that we look at, because that they do have a very detailed document which explains how to set it up, how to run their scans, and how to even set up their scans and stuff. I can also maybe share the reference for that, where which can still help in using the tool.
Sure, you can share those references, and as I mentioned, we will add it to the webinar homepage.
Yeah, yeah.
So yeah, Dayananda asks the question, how do we find vulnerabilities in the cloud?
Okay, so again, these this is again very generic, and again a whole different topic on cloud related vulnerabilities. So I mean, this is we just for Q&A. I think this is a very big topic to talk about, finding vulnerabilities in cloud. Again, I think what I can do is we can have a reference for that. Like one thing that I previously posted on ScoutSuit. That is something that you can still explore, which can help you run crowd related scans and stuff. Uh, Also, I think I think that is a topic, I think which can have a webinar by itself.
Sure. So Dayananda, that's an extremely broad question, and Suchit might not be able to answer it in the short time span available. In fact, it is something that merits a separate webinar. So maybe we can focus on that. Yeah, I think we have a question from Prajwal now, who says, which is the best tool from open source intelligence OSINT for information gathering?
Okay, so yeah, let me answer in this way. So OSINT is itself something, a process where you gather information, like it's a information gathering process, right? And it involves a lot of process within. I mean, it's OSINT cannot be done with a single tool. I mean, there is no tool that performs whole OSINT for you. I mean, it requires it's basically open source intelligence. So where you perform your investigations, try to do your own research based on the data that that is available publicly. I mean, it's basically a thing that you do based on, or the data that you find based on the publicly available resources on the internet, right? So there is no single tool that can give you a complete result for a OSINT. OSINT is it always involves a manual process where you will have to uh, where you will have to perform a lot of manual research on the target that you have. But I can still give some references or tools that can be used for this. One thing is called Spiderfoot. Spiderfoot is it's also an open source tool. Um, that has a very good set of tests that it performs. You can explore it. I mean, you can just Google for Spiderfoot. That will help you. Lot of OSINT involves around a lot of different phases and a lot of different types of analysis that can be done on that, because OSINT is very broad. I mean, it depends on what is that your target, what is your target, or what is your goal. I mean, OSINT can be done on a person, on a organization, on or a specific thing that you're looking for, right? So it depends on what is that you want to do, and based on that there are a lot of resources that are available, a lot of tools that are available. I mean, if you just search for OSINT tools, I think you get like hundreds of results. So again, what I would say is, it completely depends on what kind of, what is the goal. And again, this is a very manual process. OSINT is a manual process, but you can make use of tools to make it a little easier for yourself, so that you can gather data easily. But I mean, yeah, one thing is that you can still look at this tool called Spiderfoot. It is very good, and gets a lot of information from different sources.
So Prajwal, we hope you got the answer to your question. OSINT as a concept itself is quite powerful, but there are certain specific tools that can be used which would answer your question. I think, yeah, there's a user who's identifying himself or herself as only yes. And yes asks the question, how can we use the Dex to jar tool?
Again, this is again around the Android patch. So I think the tool itself is very straightforward, where you pass a particular file to this, and it basically gets you the jar of that. So again, I mean, the Dex to jar has a very good documentation which explains the usage. If you can just Google Dex to jar, I think you get the response of GitHub repo. I think which you can still follow the README of that particular repo, which clearly explains how you can use the tool. Bunch of options they have very nicely explained, like what the options mean, and how and when what can be used. So I think it's the documentation itself is pretty good to understand the usage of tool.
Okay, I think we have one question which I believe is going to be the last question for today.
Okay.
It is from Sumit, who asks, Sir, demonstration of cloud security process for any application. Please explain the concept.
uh Again, like I said, this itself is a whole topic,
Okay.
which requires a lot of time to talk about different or various areas and concepts that we can look at the cloud security and assessing and analyzing the cloud. Very difficult to answer as a question.
Okay. So thank you very much, Suchit, for delivering this excellent webinar on application security tools overview, and for very patiently listening and answering to all the questions of the participants. So we will now go ahead with the assessment. And I think you can sign off now.
Sure. Thank
And you
you.
can share with me the links which I'll place on the webinar homepage.
Sure. I'll be sharing the the references and links.
Sure. Thank you.
Thank you.
Okay, dear participants, it is now time for our assessment. So as I had mentioned, the assessment will be open for 1 hour only. The assessment is going to be done through Google Forms. I will paste the assessment link in the chat box. The assessment link will also be provided on the webinar homepage, which can be accessed from the SciSec website. I'll paste that link also on the chat box. It is now 4:57, so assuming that we start within the next 1 or 2 minutes, you may think that this test will be accessible only for 1 hour, so that will be up to 5:57 or 5:58 p.m. The test will contain 15 questions. Each is of a multiple choice question answer type, MCQ. There will be 4 answer options, of which only one is correct. And you will have to select one option for each question in response to each question. There is no negative marking, and it is to your advantage to attempt all the questions. You will need to score 10 points or more than 10 points to be eligible to be awarded a certificate.